Hi, welcome to Lesson 1.4, Skill 1 Questions in Action. You may recall that the AAMC has identified 4 key skills that are going to be common to all of the science sections. And Chapter 1 of your lesson book, and all of the lessons about Chapter 1, were about teaching you techniques for attacking what the AAMC calls Skill 1 questions. So in lesson 1.4, we're going to go back over a lot of these techniques and combine them in the way that you will on test day in order to earn points on Skill 1 questions. I'm Tyler Farah. Let's begin lesson 1.4. In your MCAT class, you've learned a bunch of skills that will lead to test day success. And I can be confident saying that because these skills actually come from the test makers themselves. Here's a quote from the test makers about Skill 1 questions. What I'd like you to do is read this over and then answer this question. In your own words, what are Skill 1 questions asking for? Skill 1 questions are the content questions of the MCAT. You see, recognize, recall, and define basic concepts in science, and these represent about 30% of the questions that you'll see on test day. So they're really important. But just because the test makers use the words basic concepts, that doesn't necessarily mean these questions are basic. Some of them can be quite tricky. Now, in this course, you looked at lesson 1.1 and 1.2 from chapter 1 all the way back in Chem Phys 1. And then you came back for 1.3 in Biochem 1. Revisiting topics or test skills is a great way to make them stick. So in this lesson, I want to take one more look at Skill 1 questions now that you've got a lot more familiarity with the MCAT in general. Specifically, we're going to review how to spot and solve Skill 1 questions, and then we're going to cover one more technique for organizing your study in a way that will help you master the science needed for Skill 1 questions. Since Skill 1 is a pan-science skill, our science topics in this lesson span a whole bunch of the sciences, from chemistry to physics, psych, soc, and biochemistry. And in our first 2 learning goals, we're going to look at progressively more challenging Skill 1 questions. The first one is going to be straight up fact recall, the kind of question that makes for the solid foundation of a strong MCAT score. So here it is. This one is about as Skill 1 as they come. This is literally, do you know this trend? There's just one slight danger on this kind of a question, which is that it's such a straightforward question that you could rush through it and actually make a silly mistake. So it's worth a few seconds to apply your strategy. First up, assess. This is a Skill 1 content question, so if you know the content, do it right away. Plan. Think for a second about the underlying science content. In fact, I always like to mentally name the content area. So I might mentally say something like, this is a periodic trends question. Now execute. What is the trend? Well, electronegative atoms are found in the top right of the periodic table. So answer. This question is basically asking which of these atoms is the top rightmost on this table. Take a second and make your selection now. And the answer is nitrogen. You might just have known that nitrogen is the 4th most electronegative element after fluorine, oxygen, and chlorine, and that's the point. In any case, Skill 1 questions are all about science content knowledge. Now, way back in Chem Phys 1, you learned to, quote, recognize and recall scientific principles when given a specific example. Question 2 exemplifies that skill. We've got specific compounds, we're comparing them to each other, but the rules of the game haven't changed. In general, start any Skill 1 question by naming the content area. Take a second and name the content area for this question now. So this question has nitroacetic acid, acetic acid, it's got pKa values. This is definitely going to be an acid-based chemistry question. And therefore, for our plan step, the age-old question is, what makes a compound more acidic? Well, a more stable conjugate base is the answer, so execute. Our prediction can be anything that makes nitroacetic acid's conjugate base more stable is going to make nitroacetic acid a stronger acid. Take a second and find the answer that stabilizes nitroacetic acid's conjugate base. So choice B is a perfect match. After deprotonation, the conjugate base will have a negative charge, and the electron withdrawing nitro group helps spread that negative charge around, stabilizing the conjugate base. For wrong answer choices, A and C have nothing to do with stabilizing the conjugate base, and D is actually scientifically inaccurate. Any carboxylic acid will be resonance stabilized upon deprotonation. The takeaway here, though, is that some Skill 1 questions give you a specific instance of science in action. Still, identify the underlying content first. Now, this third question is a little tricky. It directly asks about ester hydrolysis. But look at these molecules. What do they all have in common? They've got that same ester group, and they've all got the same aromatic ring. But they're different by the group that's attached to that aromatic ring. So A's got an ether, B's got a halogen, C an R group, and D has a nitro group. So this question is really asking, what do these peripheral functional groups have to do with ester hydrolysis? Actually, even a step further, why do these functional groups even impact the reactivity of the molecule at all? That's the content that underlies this question. So think for a second and answer the on-screen prompt now. What effect do these functional groups have on the reactivity of this molecule, and why? The answer is electronegativity. Ester hydrolysis relies on the carbonyl carbon acting as an electrophile because it's partially positive charged. So anything that pulls electron density away from that carbonyl carbon, like maybe a very electronegative electron withdrawing peripheral group, that's going to help activate that carbonyl carbon, making the molecule more reactive. So basically what this question is asking as we move into our answer step is, which of the following functional groups is the most electronegative? If you can answer that question, that will be the answer to this question overall. Take a second and find that answer now. The correct answer is letter D, because the nitro group consists of nitrogen and oxygen, which are both very electronegative, and that group, therefore, is the most electronegative of all. Now, one essential takeaway of this question: it asks for an application of basic science facts, and that means that if you strip away the layers of this question, you reveal a pretty simple question about electronegativity. In fact, question 3 is actually really similar to question 1 from a moment ago. The difference is that question 1 straight up asked about electronegativity, where question 3 tried to hide it in some way. Hence the Kaplan tip. Skill 1 questions could directly mention a science topic. They could give a specific example where you've got to identify the topic, or they could even try to hide the true topic being tested. In any case, the key to a Skill 1 question is to find the science topic that this question is asking about. So, you've seen that content is very important for Skill 1 questions. In the second half of this video, we're going to take a look at a mechanism for learning more science content more efficiently. The third learning goal of lesson 1.4 is all about learning to organize your study in the way that's most efficient. Specifically, on the MCAT, you often need a very superficial understanding of science concepts, and only rarely do you need a very, very deep understanding. So you can prioritize your science study around that principle. Here's an example. Look at the 3 questions on screen. The first question is just a straight up fact about science. Take a second and answer the first question. What does an ammeter do? So an ammeter is a device that measures current. These kinds of questions are really the most superficial understanding of the sciences. But fact recall is also fundamentally important, because before you can answer or understand the deeper connections between facts, you got to know the fact. And definitely, some MCAT questions are going to ask for straight up content recall. So when you're studying flashcards or taking notes on your book, you're learning this most superficial layer of facts. But the MCAT will often take things further than just fact recall into the realm of applications. After you've learned the facts of a science, your next step is to learn applications. Consider this example. Should an ammeter be wired in parallel or in series? You might actually know the answer to this question off the top of your head, so answer it now. The answer is in series. But the cool thing about applications is that if you know a few superficial facts, you can combine them into deeper applications. Here's what I mean. Let me rephrase that question to ammeters should be wired in series. Why? Well, another basic fact about currents is that the current through two elements in series is equal for each element. So if I want to know the current through the resistor, I set up my ammeter in series, and then the current through the ammeter is equal to the current through the resistor. But what we've done here is combined two superficial facts. Ammeters measure current, and current is equal for series wired things to make a new, deeper fact. Ammeters should be wired in series. So you can memorize that new fact, or you can always derive that new fact. And that gives you confidence, because if you forget this fact about wiring ammeters, you can always access it again using logic. The key for your prep is recognizing that combining facts into applications is a skill, not just memorization anymore. And in these on-demand videos, and as you take and review practice tests, you're developing that skill. The MCAT does expect you to be able to go one layer deeper still. And that is, what if the MCAT gives you new information? Maybe an experiment goes wrong. Maybe new evidence contradicts established facts. Maybe, as here, the equipment used is defective. How does that new information change what you already know? Try it out here. If the ammeter has non-negligible resistance, how will that change things? Well, if the ammeter has resistance itself, the overall resistance is going to go up, so the overall current goes down. And so by trying to measure the current, you've actually changed the current, which is pretty much just an epic fail. Now, the important point is, this is such a hyper-specific fact about ammeters, which are already a pretty specific science topic. It just isn't worth memorizing this fact on its own. This depth of knowledge, where we're taking new facts and thinking about how they change things, this is pure skills-based. And it's really a tie-in to our next fundamental MCAT skill, which is critical thinking. But more on that in lesson 2.4. But right now, remember, learn the basic facts, learn to apply those basic facts, and when you're asked how new information changes basic facts, that's where you rely on critical thinking. Let's try the same game in biochemistry. First up, a fundamental fact about FADH2. How does FADH2 contribute to the electron transport chain? Well, FADH2 is an electron carrier, which is oxidized by complex 2 in the electron transport chain. And so the electrons from FADH2 go on to generate a proton gradient, which ultimately helps make ATP. Again, you gotta know the facts first. Here's an application. In what way does complex 2 interact with the citric acid cycle? The citric acid cycle and the electron transport chain are often conceptualized as being separate processes. Like NADH and FADH2 are first made in the citric acid cycle, then they're passed along to the electron transport chain. And actually, for NADH, that's true. It's made first and then used in the electron transport chain. But now, think about how things are different for FADH2. And again, think about how we can combine pieces of information to draw new conclusions or applications. Fact 1, FADH2 is produced by succinate dehydrogenase in the citric acid cycle. Fact 2, succinate dehydrogenase is part of complex 2 in the electron transport chain. So actually, these two processes are linked together because both the citric acid cycle and the electron transport chain share that one enzyme, succinate dehydrogenase. And then the third question, and again, we're looking at the input of new information. If we're asked about reduction potentials, then now we're talking about redox chemistry and Gen Chem. So this represents a deeper connection because in it, we're now connecting two different sciences. And again, it's probably not worth memorizing this particular fact. It's so specific, and you could always derive it again on test day if you need it. But let's do that now. First, what is reduction potential? It's technically an EMF value associated with being reduced. If the value is positive, then a species will spontaneously be reduced, and the more positive, the more likely that thing is to get reduced. So take that Gen Chem information and apply it to this scenario. Answer this question right now. Generally, the compound with the greater reduction potential will be preferentially reduced. So in this schema, electrons flow from FADH2 to coenzyme Q. It simply must be true that coenzyme Q has a greater reduction potential. One more go at this. Basic fact, think it over. What is the Cannon-Bard theory of emotion? In Cannon-Bard, a stimulus causes both physiological response and emotional response together. This theory was a direct attack on the James Lange theory, which said that emotions were the result of physiological states. A little deeper is application. How do the Cannon-Bard and Schachter-Singer theories relate? You've got to know some basic facts about both theories in order to compare them. That's the application. Let's combine basic facts about Cannon-Bard and Schachter-Singer to get a brand new observation. We already looked at Cannon-Bard theory, so let's look at Schachter-Singer. And in this theory, a person experiences physiological arousal and then attempts to label that arousal as an emotion based on her immediate surroundings. For example, scientists have taken people with social anxiety, given them a caffeinated beverage, and then placed them in a social situation. And these people attributed their physiological arousal, their jitteriness, to the caffeine rather than to social anxiety. So Schachter-Singer is similar to Cannon-Bard in that both of these theories attempt to explain the origin of emotions. And it's also similar to Cannon-Bard in that both of these theories look at the role that physiological arousal plays in the experience of emotions. But the theory of Schachter-Singer is different from Cannon-Bard and actually a lot more like James Lange in that emotions are the result of physiological arousal in Schachter-Singer. So here's a last point about applications. It's a lot easier to remember Schachter-Singer as a kind of middle ground between James Lange and Cannon-Bard than it is to remember these as three separate and distinct theories about emotion. As you continue to study for the MCAT, look for connections and applications of knowledge that you already have. One layer deeper. How might the Cannon-Bard theory be influenced by new information? What if someone were unable to perceive her physiological changes? In Cannon-Bard, the physiological and cognitive elements of emotion happen simultaneously. So if a person lost her ability to experience the physiological arousal of an emotion, she should still feel the cognitive element of that emotion. Now, an interesting thing happens when you think about the same question, losing physiological responses, in the context of the James Lange theory. In that theory, emotional responses depend on physiological arousal. So if you lose the ability to identify physiological arousal, you should also lose your emotional response as well. Imagine an MCAT passage that presents an experiment in which patients have lost the ability to physiologically respond to environmental stimuli. You can see why these kinds of comparisons could become important. But the takeaway is this: how things change in response to new information. This is now so specific, it's probably not worth memorizing. Instead, if you saw a passage about this or a question about it on test day, you'd rely on critical thinking skills to find your answers. Let's end by reviewing all the learning goals from Chapter 1. In 1.1, we looked at Skill 1 questions of varying difficulty. Those that ask you to recall science, those that give you a specific example, and those that were even somewhat misleading. And in fact, we returned to those three types of Skill 1 questions in this lesson. In 1.2, you looked at math on the MCAT. And the point of that lesson was that often you don't need to solve on the MCAT. You need to pick the right answer out of 4 choices. And then in lesson 1.3, you looked at the same science fact being tested in different disciplines. So that's it for Chapter 1, which is all about Skill 1 questions. You've seen that the best way to improve your odds on a Skill 1 question is to get a firmer mastery of the science content itself. But remember, studying science content doesn't necessarily mean just reading your books. Sometimes you can learn just as much from attacking practice problems and reviewing your mistakes.